9.1, exploring rational functions using transformations. A rational function is any function that can be written as p of x over q of x. So it's a ratio of functions. Where p of x and q and x are polynomial expressions, and q of x can't be 0. We can't have 1 over 0. So that is what a rational function is. And now we're going to use transformations to look at them. So what we're going to always compare to is the graph of y equals 1 over x, or y equals 1 over x. Okay, so what we're going to do is we're going to put some test points and we're going to see what this graph looks like because we're going to compare every other graph to this. Okay, every other polynomial function. So x and y, if x is negative 2, and I chose these points because I know where I'm going. Okay, so 1 divided by negative 2, if I put negative 2 there, we would get negative 1 half, negative 1. 1 over negative 1 is just negative 1. What about negative 1 half? 1 over negative 1 half. Well, that's like 1 divided by negative 1 half. You kiss and flip. So it's 1 times 2 over 1, negative. So in other words, that's just negative 2. 0. 1 over 0, well, that does not exist. Okay, now we're going to go up positively. 1 half. 1 divided by 1 half is the same as 2. 1 over 1 is 1, and 2, 1 over 2 is 1 half. Okay, so let's see what that looks like. Let's plot those points on your graph. And this is going to be a really good reference that we're going to use. Okay, so we have negative 2 and negative 1 half somewhere here. We have negative 1 and negative 1. And then we have negative 1 half and 2. So somewhere there. Then we have does not exist. Then at 1 half, this graph is at 2. At 1, it's 1. And at 2, it's 1 half. And in fact, if we put in more points, we would see, like if we put in a quarter, if we put in an eighth, if we put 1/1,000,000th, it just keeps increasing up. 1 over 1/1,000,000th is a million. Okay, and as we got bigger, this would just get closer and closer to 0. Similarly, on this side, it looks something like this. Okay, so this is what the base graph looks like. From that base graph, we should be able to see our asymptotes. So we have an asymptote right here, and we have another asymptote right here. So the graph always gets really close, but it doesn't quite equal. So here we have y is equal to 0 is one asymptote, and here we have x equals 0 is another asymptote. And let's just fill out the information under here. So my asymptotes are x equals 0, y equals 0. The domain is all at x such that x does not equal 0, but everything else. The range, all y such that y is not 0, but everything else is okay. Okay. And then some key points. One of the key points is going to be negative 1 and negative 1. Another important point is 1 and 1. Those are kind of key points that we're going to use. Okay. Okay. Now our dear friends A, H, and K. No B here, so we're in a good place. My general form I'm going to use is going to be A over x minus h plus k. Okay, so this is the general form that we're going to use. Now, your task right now is to graph each of these functions, y equals 1 over x, 4 over x and 12 over x. So basically all I've done is I've changed this a value and I want you to tell me what's happened. Describe the behavior of these functions as x approaches 0 and what happens as x becomes larger. So what's the relationship? What does a affect? Okay, so you need to pause this video, do that activity, and then start again. Okay, hopefully you have tried that activity. Now you're going to do a similar activity. You're going to compare y equals 4 over x. This is just written a different way. And y equals 4 over x minus 3 plus 2. And you're going to see how the h and the k affect the graph. So you're answering how do they compare and what are the asymptotes of this graph right here. How did that change the asymptotes when we shifted? Okay, so you're going to be using Desmos and trying that. Another one here is y equals negative 12. So what happens when we have a negative a? X plus 1 minus 5. Okay, you're going to predict and then graph to check it. So that is another activity you're going to do. Pause and then come back. Okay, so hopefully you saw that A was your vertical stretch. H is your horizontal translation. It also gives a non-permissible value and the vertical asymptote. K gives a vertical translation and it gives the horizontal asymptote of x equals k. Okay. So sometimes we're going to have functions that are not in the form we want. They aren't y equals a over x minus h plus k. So here's some steps to convert it. And I'm going to do an example with you. It says, first of all, look at the leading coefficient of the numerator. So I'm just going to rewrite this in the way that so I can clearly see the numerator and the denominator. Okay, so the leading coefficient is the number in front of the highest power of x. So this number here, 4. Look at that. Look at the factor in the denominator. Well, that's x minus 1. Add and subtract a times the non-variable of the denominator's factor to the numerator. Okay, so here's the non-variable part, negative 1. I'm going to add and subtract 4 times negative 1 to the numerator. Okay, when I add and subtract, just like when I was completing the square, totally allowed. Okay, so I have 4x, I'm going to go minus 4 plus 4 plus 2 over x minus 1. I'm going to make that a different color to show I added and subtracted something. So this is what I had, 4x plus 2. Then I subtract and add 4. And you're saying, well, why are you even doing that? Well, watch this. Here on the top, now this can become 4 times x minus 1 plus 6 over x minus 1. So all I did is I zeroed in on these first ones. I took out the common factor of 4. I was left with x minus 1. Now I'm going to split up this fraction the way I'm allowed to. So remember, when we have a common denominator, we can combine or we can separate. Now look at this. I have 4 over x minus 1. 4x minus 1 over x minus 1. That cancels out. So I simply have y equals 4 plus 6 over x minus 1. I'm just going to rewrite that order. And you can see that now I have it in the form I wanted. What I wanted was y equals a over x minus h plus k. So my a value here is 6. My h value is 1, not negative 1, careful. And k is 4. So that's a little trick for the assignment we're going to do. You're going to have to be able to convert back and forth.